Hello dear students, welcome to the channel and very welcome to this playlist in which we are discussing 8051 microcontroller in detail. And up until now I know we have already discussed about architectural block diagram and pen diagram. In detail we have discussed about different type of ports that are available, and we have discussed about the memory organization, addressing modes, and instruction sets, group of instruction sets, everything in detail. But today I'm going to discuss about the port programming of 8051 microcontroller. So in the previous one of the previous videos we have discussed about the ports and their circuits in 8051 microcontroller in detail. So let me quickly show you port 0, port 1, port 2 and port 3. We have four ports, each of them consisting total 8 different pins, and we have discussed about that in detail. So if you want to check out the details about the circuit diagram of different ports of microcontroller, check out the video which will be flashing on the top right hand side corner of your screen in the I button. So just click on the link and you will be redirected to that video, so you can check that out and learn it. And now that out of the way, now let's come to input output programming of 8051. So as I've said, we have four ports: 0, 1, 2 and 3. So examining this pin diagram that you are seeing here, you can see 40 pins, and out of these 40 pins, 32 pins only, total 32 pins have been allocated to this uh, four different four different ports. Okay, and only remaining 8 of the pins are designated to remaining work or remaining tasks, right? And if I want to ask you, as you have already studied the pin diagram earlier, which would be these pins which are dedicated for different tasks? So one you see right here, you have VCC, you have ground, these two clock circuits, remember. Then we had the reset. Can you locate the reset for me? Right, sure, pin number 9 is the reset. We have EA, we have ALE and programming, PSEN. So these are different different pins except for these four ports. But today's our topic is these ports. Okay, port 0, port 1, 2 and 3. Each uses 8 pins, which makes them 8-bit ports, and all the ports upon the reset are configured as the input ready to be used as input ports, and when first 0 is written to a port, it would become output. So to reconfigure it as an input, a 1 must be sent to the port. And I'm telling you, remember this every single time that you are dealing with the ports, that to reconfigure this, okay, let me start from the start. uh, all the ports upon reset are configured as inputs, and they are all of them are ready to be used as input ports. So when the first 0 is written to the port, it becomes an output, and in order to reconfigure it, reconfigure it, and in order to make it an input, 1 must be sent to that port. So always remember this. And to use any of these ports as an input port, you must have to program them, right? It goes without saying, pretty much simple. So you first have to program them. Now let's see each of these ports one by one in detail. So first we have the port 0. Port 0 occupies total 8 pins, and it can be and which pins, if you can see from this pin diagram, you can see pin number 39 to pin number 32, right? Or pin number 32 to 39, you can count the way you want, ascending or descending, doesn't really matter. So this port 0 can be the pins of the port 0 can be used for the input or output purpose, both of them. And again, I'm telling you to use these pins of port 0 as both input and output port. Each pin must be connected externally to the 10,000 ohm pull up resistor. Okay, you need to connect them with the 10,000 ohm pull up resistor. And I'm talking about each and every single pin. Okay, I'm not talking about the port in general, I'm talking about each and every single pin. So you must need to connect each and every pin with the externally 10,000 ohm pull up resistor. And this is due to the fact that P0 is an open drain, unlike P1, P2 and P3. Okay, we will see when we will see what is open drain when we will talk about P1, P2 and P3. But for now, know that P0 is an open drain. Okay, okay, let me tell you right now. So open drain actually is a term used for MOS chips, and we use them in the same way that we use in the open collector, right? So what is open collector used for? Open collector is used for TTL chips. So in any system we are using, be it 8051 or 8052 chips, we normally connect P0 to pull up resistors. Okay, and by connecting them, we take advantage of port 0 for both input and output, right? So that you can do. Now let's talk about port 0 and input and output, both of them one by one. So with resistor connected to port 0, in order to make it as an input, the port must be programmed by writing 1 to all the bits. And in the following code, port 0 is configured first as an input port by writing 1 to it. And then the data is received from port 1 and port and sent to P1. Okay, so I'm repeating one more time. With resistor which are connected to port 0, in order to make it an input, the port must be programmed by writing 1 to all the bits. Okay, and let's not discuss the code right now, because I think we shall arrange a separate video for the code. So let's discuss the code in the upcoming video. So I'm leaving the code part here. But there is a due role in the port 0. So port 0 is also designated to 80 to 87, as you all know, and as you all can see in this diagram. So it allows it to be used for both address and data buses. And when it is connected at 8051 to external memory, the port 0 provides both address and data bus, right? So the multi this will the 805 will multiplexes the address and data through port 0 through port 0 to save pins, and that is why we only have 40 pins. Now let's quickly move to port 1. So port 1 occupies total 8 pins. As you can see, pin number 1 to pin number 8 has been occupied by port 1, and it can be used as an input or output both again. But in contrast to port 0, this port does not need any pull up resistor. Okay, it does not read any pull up resistor. Why? Because it already has the pull up resistor internally. Now I'm repeating it one more time. Upon reset, port 1 is configured as an input port. So if you want to write any code, it will continuously send to port 1 and implied as an input. So when we want to use port 1 as an input port, but first you have to check if it has been configured as an input port or output port. If port 1 has been configured as an output port, so to make it an input port again, it must be programmed such by writing 1 to all its bits, right? So the code for that, if you want me to discuss upon it, we will discuss that too. I think we shall make a separate video on it on your demand, so we will make it too. Now coming to port 2, again port 2, as you can see, it occupies total 8 pins, pin number 21 to pin number 28, as you can see. A8 to A15 buses it contains, and it can be used as an input and output port too. And just like port 1 which we saw just now, just like the port 1 which we just saw now, port 2 does not need any pull-up resistor, because again it already has the pull-up resistor inside of it. It has a pull-up resistor internally. So upon reset, port 2 is configured as an input port, and the uh, code whatever you want to use as an input, you can use it. Now what if the port 1 is not configured as an input port initially? So you have to make it an input port, and to make port 2 an input port, it must be programmed such by writing 1 to all of its bits, right? Same as port 1 and port 0. One more thing, that port 2 also has the due role. So in many systems which are based on 8051, port 2 is used as simple input output, but in some of the systems, I don't exactly remember the number of the microcontroller, but there are some 8031 based system. Port 2 must be used along with P0 to provide the 16-bit address for external memory. Okay, so port 0 and port 1 cumulatively provides you the external memory. And port 2 is also designated as A8 to A15, as you can see here, which indicates the dual function. And since 8051 and even 8031 is capable of accessing 64 bytes of external memory, it needs the path for 16-bit address, while P0 provides the lower 8 bits via A0 to A7. It is the job for P2 to provide 8 to A15 of the address. If you want me to explain it in other words, when P051 or P031 is connected to the external memory, P2 is used for upper 8 bits of the 16-bit address, and it cannot be used for input output operations. Right? Simple enough. And now from this discussion so far, we can conclude that the system which is based on 8051, like the family of this 8051, so we can say that the systems which are based on 8051, 8751, 89C51, so these microcontrollers, we have all these ports P0, P1, P2 for input output operations, and this should be enough for the microcontroller applications. But we all know P3 port is different from P0, P1 and P2. So how is it different? What how will be dealing how will we be dealing with it? So port 3 occupies total 8 pins again. You can see pin number 10 to pin number 17 has been occupied through by port number 3, and it can be used as an input or output port. So P3 does not need any pull-up resistors, just as P1 and P2 did not. But still, P3 is configured as an input port upon reset, and this is not the way it is most commonly used though, because port 3 has the additional function of providing some external important signals like interrupts. Okay, not external but important signals like interrupts. So as you can see here, and we have also discussed when we have discussed about port 3, whatever the application does port serves. But coming to its input output operation part, that port the pins of the port 3 are used for reading and writing operations as well. You can see pin number 16 and 17 here, and we use it for the serial communication signals as well. Use it for serial communication as well. You can see here pin number 12 and 13 are set aside from external interrupts or included as external interrupts. Bits 3.4 and 3.5 are timers 0 and 1. We have discussed about that in detail as well. And we have read and write signals for external memory connections in 8031 based systems. Okay. So sometimes in systems which are based on 8751, not 8051, I'm talking about 8751, 89C51. In such systems, pin 3.6 and 3.7, the read and write pins are used for input output, while the rest of the pins in port 3 are normally used in alternate function role. So that was the programming of input output pins or ports in 8051 microcontroller. So we will keep today's class short, and we'll discuss new things in next video. If you have any doubts, queries or questions related to today's class, please mention them in the comment section below. I will try to answer them as soon as possible. If you have any suggestions, if you have any video recommendations for me to make, you can suggest that in detail as well. I will work on it. And if you have any feedback related to the channel, each and every feedback is important to us. So please provide us the feedback and tell us whether we are going in the right direction or not. So we will wrap today's class here. Thank you very much for listening. I will be seeing you in next class with the next video. So till then, take care of yourselves. Thank you very much for listening, and goodbye for now.